So domains, range, and function values are something that are important that you know how to do. They especially come up if you take college algebra or calculus in your future. So let's talk about domain and range. So first, let's talk about domain. Domain is defined as the set of inputs, usually we make those x's, that work for the function. Domain is the set of inputs or x's that work for the function. That's why for square roots, only positive values work. So we set the inside greater than or equal to 0. So square roots inside is greater than or equal to 0, and fractions, the bottom isn't allowed to equal 0. Okay, so the domain are the set of x's that work for the function. So for square roots, that would be the inside is greater than or equal to 0. The fractions, the bottom is not allowed to equal 0. Now, if it's something like a polynomial, like a quadratic, like x squared plus 7x, those domains are all real numbers. Nothing messes it up. So everything works. So sometimes everything works. Sometimes nothing works. It just depends on the function. Now, range is the set of outputs, or the y's, or the f of x's. Okay. Usually you have to use the graph for range. There's not a great way that we know mathematically to do it in a Algebra 3 or college algebra course, so you kind of just have to look at the graph. For domain, we're going to look at the graph because it's x's from left to right. For range, we're going to look at the y's, so we're going to go from bottom to top. Okay, so as we go across the graph and look at it, for domain, how does it stretch from left to right? For range, how does it go from bottom to top? Okay, so those are the main ideas you want to think about, and we'll practice those things as we go. So we'll definitely be practicing those things as we go. Okay. So domain is a set of inputs, the x's. Range is a set of y's, or the outputs. You can also call that f of x's. So the next little piece is, how do we find a function value from a graph? Okay. So if they are looking for f of x, okay, so we're looking at some function value. So you're going to go to the x, and then you are going to find the height at that point. That would be your f of x. So your x is your left and right. Your f of x is your height at that x. So it's the height at that x. So in this class, we're going to start looking at graphs a little differently than you did in an Algebra 2 course or any courses below that. So we're just going to look at the graph, just analyzing it a little differently than you would have seen in maybe your other classes. So here, let's take a look at this graph. First, let's find the domain and range of the graph, okay? So what I think of is if I could somehow make a shadow along the x-axis, because the x's represent our domain, I think that the domain is going to show up as a shadow on the x-axis. So if we think about how it shadows on the x-axis, it could be here, all of these x's, nothing. all of these x's, nothing, okay? So if we think about how, if there was a beam of light down here, and that light was shining, and we walked this way, what shadow would it cast on the x-axis? Like, that's our wall, okay? So we would have x's here, nothing, x's here, nothing. So that's where interval notation comes into play. Our domain is going to go from -2 up to -1, and it skips it, and we show that with a parenthesis. And then it keeps going up to +1, and then we can't stand there. Like if we were a little math bug, he would fall into the hole there. So he can almost get to 1, and we show that with a parenthesis. So our domain is like if we could shadow what the x's we used onto the x-axis. What x's did you use from left to right? So it goes in least to greatest order. Now let's talk about our range. Our range is our bottom of the graph to the top of the graph. If we could somehow put a shadow of the graph along our y-axis. We have some y's here, over here, see? We have y's all the way up. We have y's here, see, we have y's here, we have y's here, we have y's here. We don't have y's here. There is nothing that filled it in here. There's open and an open. So we don't include that. So sometimes you have some repeats on your y's. It's allowed to repeat. And so we would go from -3 up to 0. I can stand on -3. I cannot stand on 0. So it's all about like a shadow on the y-axis. What y values, what heights do you come across from the bottom of the graph to the top of the graph? So this is bottom to top. This is left to right. Okay. A domain is what x's appeared from left to right. What x's am I allowed to use from left to right? The range is what y's popped out. What heights did my graph go to from the bottom of the graph to the top of the graph? So it's a very different way of looking at a graph, okay? Now let's talk about the function values. I'm going to write them up here just so I can, but if you want to type on yours, you can. So f of 0, f of -2, and f of 1. Okay. Now what does that mean? So let me erase what I had here for a minute so our graph looks a little prettier. Okay. So let's talk about f of 0. This is saying, f of 0 says, when x equals 0, what is my height? Okay, that's all it's saying. Don't overthink it. The graph, we are used to having an algebraic equation. Here we're finding this information from a graph. So when x is equal to 0, that's here, what is our height? So just find where our height of our graph is. What is our height when x is 0? What is our height when x is 0? -1. And so that would be -1. Technically, we can think about that as an ordered pair. That is the ordered pair 0, -1. See this point right here? That is the ordered pair 0, -1. Now let's do f of -2. What f of -2 is saying is when x is -2, what is the height? So you want to really get that word height into your head. So if we go over here to -2, we are down at a height of -3. That is the point, -2, -3. So our value, f of -2, is -3. That represents the point -2, -3. And finally, let's take a look at f of 1. F of 1 says, if x is 1, what is the height? Well, if you take a look, when f is 1, do we have a height that we're allowed to stand on? No, that open circle tells us that we don't have a height at that particular point. So you just say there's no solution. It isn't a point on the graph. So that's why we canpoint notation because when x is 1, we don't have a point. It doesn't exist. It just isn't a thing. Okay? So it's just a new way of thinking as you go through this process. Okay? Okay. Let's take a look at this one. It says to find the domain and range. And we have different things to look at. So the first one's the nice one. We have a list of ordered pairs. So that is called a discrete function or discrete relation, depending on if things repeat or not. So number 1 on example 2, the domain, when it's a discrete set, meaning it's just points A, B, C, and D. It's just a few points. You just list the x's. If there's repeats, you don't show them. If there's repeats, it wouldn't be a function, so that's a way to tell whether it's a function. All of our x's are distinct, so our domain just lists them. Now, sometimes I will list mine in least to greatest order if I was doing the problem myself to kind of keep them organized. But it is what it is. That is just a list of all of the x's that are used. The range is the list of all the y's that are used. So -4, -8, -7, 10, and 6. So that the domain is the list of x's that are used. The range is the list of y that is used when it is a list of points like that. Now, 2 and 3 are called continuous functions. It is continuous along an interval. So that's why our interval notation will be used for the graph of h for problem 2 and 3. So let's take a look at problem 2. So we want an interval. If we put a shadow on our x-axis, there's a dot here. This graph keeps going across, and it goes, I think, to 3. I think it goes to 3. And it uses all the values between. They're counting by 2, so be careful and always count your axes. These are counting by 2s. These are counting by 2s. Okay. It looks like it goes from -4 up to +3. And both of those dots at the end are closed-in dots. So I used all the values between -4 and +3. I could find the function value h of -4, h of -2, h of -1.6. They're all there. Let's talk about range. For the range, the lowest point looks like it's -6, I would say. If you go on up and keep it going, all those points are covered, all these points until maybe we get to +5. So the range, the bottom one is -6, the top one is +5. I used all the values in between. There's no value height that I couldn't get to. I can get to these heights. I can get to all those heights eventually, somewhere. And so range is weird because it's kind of, some of the values can repeat themselves. Does that make sense how I found the domain and range there? Domain goes from left to right, range goes from bottom to top. That's the main thing to think about. Okay, let's look at number 3. Because of the arrow on the end, be careful. That is spreading forever and ever to the left and down. I think both left and down because the left will refer to what the x's are doing. The down is going to refer to what the y is doing. So if we think about that, this graph can stretch to the left to -infinity. And then it can keep going, all the x's get used up to 4. Now this is counting by 2s again. So the domain goes from -infinity. I use all the x's from the left side all the way up to 4, and I'm allowed to stand there. You can think about the fact if I had my little math bug and he was walking, he would walk through all the x's he wanted to, but he would have to stop at 4. He can't go any further, if that helps your thinking. Now let's take a look at range. The bottom of the graph is going all the way down to -infinity. That's where I can start. I can start down as low, as long, as high, or as low as I want. And then I can, if I walk the graph, what's the highest value I will ever get to? This one's counting by ones. 3 is the highest I'm ever going to get to. So my range follows that bottom of the graph, walking up to the top of the graph. So it's going from negative infinity up to positive 3. And we assume if they don't put like a very noticeable open dot, we assume that's a point he can stand on the top of that cliff without falling over, and he can keep walking down the other side of that little cliff, that little mountain. So he can go up to a height of 3 and stand there. So we put a bracket on it to make that a thing, okay? So it's just a new way of looking at the graph. What x's appear? Go from how far left does it go? How far right does it go? Do I skip any x's in the middle? For range, how low do I go? How high do I go? Start at the bottom, work your way to the top. Okay, so it's just a different way of thinking. So ignore that part because there's not very many of them. So your job is just to do the problems that you see here and work on them right now so that you can ask me questions, and I'll walk you through whatever you need, okay?